Today we will be learning by we have supervised learning. Supervised learning is the part of machine learning that dealt with labeled data. Okay. Here we had equivalence regarding X, okay, which were our features, and we also had the target variable. For example, if I have quantities such as humidity, wind speed, atmospheric pressure, I can predict rainfall. Okay, so we have features which are independent, and we have target which is dependent upon the features. Okay, so when we talk about supervised learning, this kind of learning, it has some kind of data associated with it. Data which is basically some past records. Okay, that can be used to train the machine learning algorithm. And we got to know about various machine learning algorithms such as classification and regression. So there are majorly two kinds of problem: classification problem and regression problem. Here the category target variable it is of categorical nature, and here it is of continuous nature. When we talk about classification algorithm, K means sorry, not K means we have not studied it yet. So KNN, decision tree, random forest, logistic regression. All of these were classification algorithm. Linear regression and decision tree and random forest and KNN. So these algorithms they can be used for regression problem as all right. So we have talked about these four algorithms. We have even more algorithm. We have naive bytes. We have SVM, and we like in SVM also we have several kinds like non-linear and linear. So these are these four. They are not the only kind of classification or regression algorithms of supervised learning. Okay, we have so many, but these were few of the major ones that I thought we should discuss. Now, talking about the another category of machine learning that is unsupervised learning. So we will be discussing few algorithms of unsupervised learning now. So can you guys recall a little bit what unsupervised learning is? I taught you at the beginning of machine learning classes. What do we mean by unsupervised learning? Someone wrote in the chat box. Okay, machine learning, which is not guided, the data that we have is not labeled, is called unsupervised machine learning. Okay, so you've got some takes and data that the data is not labeled. Can you guys hear me properly or is there too much disturbance on my end? Please let me know once. Give a thumbs up if my voice is audible and there is no disturbance. Okay. So some of the takeaways that we got from unsupervised learning discussion is that the data is not labeled. Secondly, this kind of learning, it is not guided. Okay. So what do? We feed raw data to the machine, which has no labels. So how is the model going to train upon this data? So what the model does is, can you guys all recall? Yesterday I drew a graph between three species iris flower. So we had versicolor, we have virginica, and we had a set of. And we classified a new data point that was KNN, using KNN to one of these classes. So can you tell me what was your approach? Basically, apart from uh, talking about the distance that whichever data point was nearer to the new data point, we assigned it. But one thing that you observe at the beginning when you see that data is that whether there is some kind of pattern in that data, right? So here in unsupervised machine learning, the model is going to find some hidden patterns. All right. And based upon these patterns, it is going to gain some insights on the data. And how these insights will be generated basically by studying the features. So this is the same kind of learning that human brain does. If I provide you random articles, okay, let's say there are some newspapers, there are some catalog, there are some magazines, and we have, let's say, some A4 size sheets, and we have some onboarding documents. Now, if I ask guys to basically, uh, segregate this data simply, separate it. So, what you guys are going to do, you'll put the newspapers together, you'll put catalogs together, magazines together, A4 size sheet together, and the onboarding document together. Though all of them are, constituted with paper. Okay, they all are paper-based material, but you know the difference between all of these different kind of paper. You know that this onboarding form, it is quite necessary. Okay, so let's keep it separate. A4 size sheet, let's keep it separate. Okay, and we like if in our house or if in the office we have all these things lying together, we have a separate place for them. Okay, so with newspaper, it is on the reception desk, onboarding document generally with properly A4 size sheet again near the printer. So what do? We segregate this data. We put it into groups. And how do we do it? We study its outlier features or patterns. So similar kind of learning is happening in unsupervised learning. Since the model, it does not have any information regarding the labels of the data. Okay. So what does the model do? It is going to simply study the outward characteristics and then segregate the data. I also gave you an example of a baby. Uh, a baby to whom you are teaching how to differentiate between different foods. And rather than teaching that baby what is the name of each fruit, you just you just throw away some fruits in front of the baby, or let's say you throw away some apples and mangoes and lychees, and you let the baby be with these fruits for a while. Then if you put forth a fruit by random, let's say you show an apple to the baby might not know the name of the fruit, but based upon what is the outward characteristic of this fruit, the baby will say that, this fruit, it belongs to this category. Okay. And even if the color, let's say here we have a red apple and the apple that I'm producing it is somewhat green. So even if the color of the of both the fruits are different, but shape is different, and the structure is different, and if the baby is going to taste, they are going to taste the same. So despite the difference between the color, since most of the characteristics of these fruits match, the baby is going to categorize it as the apple category, despite not knowing the name of the actual apple. If I have a bunch of pictures, let's take one more example. If I have a bunch of pictures, let's say some of them are of um, a normal pet dog. You might have seen German Shepherd. And have you seen a mountain lion? A German Shepherd and a mountain wolf. They look quite similar. But being humans and being of very correct judgment, we'll be able to differentiate between the two. Okay, so such differentiation that we are doing based upon looking at various minor features of any image or of any object, we ourselves are doing unsupervised learning. Okay, so I believe that the crux of unsupervised machine learning is very clear to everyone. Please give a thumbs up. Okay, now despite all of these theoretical concepts that we have studied, that we are going to group the data. But here the main problem arises is that the data that we have, okay, it is not labeled that this is input and this is output. Here, in all of the data that we have seen so far, there is a distinguished target column or the output column, and there are some input features. But in machine learning, this differentiation between the two, it is not quite observable. Okay, there is no label for input columns and output columns. So how these unsupervised learning algorithms are going to work? All right. So we cannot apply classification or we cannot apply regression until and unless we have a clue which is the X variable here and which is the Y variable here. So there is a technique that is quite common in unsupervised machine learning, which is called clustering. Have you guys heard of clustering? Please give a thumbs up if you know anything about clustering. Okay, can you write in a few words what clustering is? Ajay, I'll give you a very common example. In my school, there used to be houses. Okay, so there was a red house, there was a blue house, there was a green house, and there was a yellow house. And on Saturday, we used to go wearing the house uniforms. So just before the assembly, everyone would be scattered in the ground. Okay, so you will see a mix of all the colors. But just when the assembly started, everyone. Okay, so red house people will be standing in their specific place, green house will be standing in their specific place, and yellow had their own place in the assembly ground, and same was with. Okay, so just like this example that I have given you, in the same manner, the clustering algorithms work. So I told you that in my school we had various houses, and just before the assembly, everyone would be scattered in the ground. Someone would be moving, someone would be talking, someone would be rushing to classes. Okay, and there would be a lot of chaos. So you could see a bunch of colorful uniform wearing students, and everyone would be running here and there. So in the same manner, we have data. Okay, so there is data, but that data it is segregated. It is not like very cleanly separated or very cleanly segregated. The data points they would be lying here and there everywhere. So though there is a definite pattern in the data, but you won't be able to observe it. Okay, since the data it is quite large. So what does these algorithms do? Clustering algorithms they just work like these full assembly. So whenever we used to hear our PT master whistle, so we would assemble in our specific lines and we would just start praying. So in the same manner, the clustering algorithm, they cluster the data points. Okay, data points which follow a definite pattern and move on. But the pattern, it is not that much observable in the beginning. And once these assembly here is the equivalent of clustering algorithm. So once this clustering algorithm occurs, you can see that there is a definite pattern in the data. And now, let's say there is a red house student who is late to the assembly. So since this student, they are wearing the same uniform of red color as the red house people are wearing. So what I would do, I would make him stand here. If a greenhouse student comes late, okay, so I would make him stand here. So now since I have done what? I have made clusters of these data points based upon similarity of their uniforms. So if I have a new data point, I can look at their uniform and I can make them stand at their specific hours. I believe it is clear. So clustering means forming groups of similar data. And these groups, they are formed based upon the outward characteristics. So like if I have like here only, if I take you to the previous example where we had these different categories of paper. So we had newspaper, catalog, magazine, A4 size sheet, onboarding doc. So when I have so many of these documents lying around, okay, based upon their outward characteristics, I'm going to segregate them. I'm going to form groups of them, and this is called cluster. And then I keep them at their assigned place. And then if I have an onboarding form, someone's onboarding form lying around, I know whom to approach, I know where to get it. Okay, in order to uh, maintain cleanliness in your office. Okay, so similar kind of thing happens in unsupervised machine learning. So the unlabeled input that you have, unlabeled input like this one, you feed it to the machine learning algorithm, and the output that you have. Okay, we have like various clustering algorithms we're going to talk about. The output is very clean with distinctive pattern that you are able to observe. There is one principle, underlying principle associated with clustering, and that is quite easy to understand, a very basic thing. So the clusters that you have, they are formed in a manner that the points within the cluster, they have higher similarities. Obvious, right? And the points which are away from a cluster or which belong to different cluster only, they have higher dissimilarities. Since here I have grouped my data based upon the color of uniform, I can very clearly observe that all the people, all the students belonging to Red House, okay, they will have one thing common in them, that is their red uniform. Okay. And their uniform, it would be quite different from these two clusters. Okay, the other clusters that we have. Similarly, we were talking about fruits in the earlier example. So if I compare, let's say we have category A, which is of apples, and we have category B, which is of mangoes. Why I'm talking about categories here? Because this data, it is not labeled. I do not know that these are apples and these are mangoes. Okay, but since I cannot draw, so I have written the names. So this is the category A and this is the category B. And we know that all the data points belonging to this category, they are quite different from the other category, but very similar to the data points in the same category. I believe it is very easy to understand for you guys now in great depth with great simplicity. We have learned what clustering is. Just give me a minute. My laptop is charging. So, talking about, we have talked about clustering in great detail. So, let's discuss few of the advantages and disadvantages of clustering. Okay. So, what is clustering advantages of? So, clustering, it is going to help me find hidden patterns. Okay. From very unstructured data. the data is quite unstructured. There are no labels, so no supervised learning algorithm will work upon them. So here clustering is helping me. It also creates a partition in the data set. Just like if you can recall the graph that I made for iris with three different species yesterday. So you'll be able to recall that in that graph there was a distinct partition between the three classes. And when we heard about, I cannot recall what we were discussing. I think we were discussing about classifying the data with some. Okay, leave it. So yeah, you guys can recall about iris data set, and there was a clean partition between that data set. So that is possible with the help of clustering. Though please remember that KNN is not a clustering algorithm. Okay, it is a classification algorithm of supervised learning. Now it is help since it is very helpful in various things such as image segmentation. Okay, so if we have a bunch of images lying around and we want to segregate them, want to uh, categorize them, we can use clustering to do that. And we can also use it for anomaly detection. Now, can you tell me what an anomaly is? Please take some time and tell me what an anomaly is. Yes, guys, can you tell me what anomaly is? Okay, so let me tell you. So someone has, I don't know, maybe, no. Analogy is different thing. Analogy means that you are applying just like here I have an analogy for supervised learning. Basically, an example that, sorry, unsupervised learning. Basically, an example, okay, that is quite similar to the actual process. That is analogy. Anomaly means some kind of, you know, the data it is deviating from the pattern, not following the pattern. That is anomaly. Basically, you know that gravity is 9.8 everywhere, but if there is a place where gravity is 11.20, so that will be an anomaly. Yeah, irregularity. So anomaly detection is very easily uh, can be very easily processed with the help of clustering. And why is it so? Because since I have found some pattern in my dates, let's go here. I have these four houses, red, green, yellow, blue, and then someone comes wearing a pink uniform. And that person, okay, I'll be able to distinguish that person from a very far away. So this is how clustering helps in detecting anomaly, since you have very distinct groups of data. Now, if a data point that is very far away from all the data points, that would be easily detected. So basically, outlier. Now, let's talk about few of the disadvantages. So, when talking about disadvantages of clustering, can you guys think of any disadvantage? Like, take some time to brainstorm. Can you think of any disadvantages? Okay, let me tell you. One of the very major disadvantage of cluster is that you need to define the number of clusters. Loop through each, so might be time consuming. Yeah, it is definitely time consuming. And also all the clustering algorithms, they require you to define the number of clusters. Just like in KNN, we had to define K value, that is how many nearest neighbors. So all the clustering algorithms, they require you to define the number of clusters. Then if the data, okay, if there is some kind of non-spherical pattern in the data, right? Mostly, the clusters that are formed, they are of spherical nature. Okay. But if there is some kind of non-spherical data, so it is difficult to perform clustering. I am saying that it is not impossible, but it is difficult to perform clustering on that data. And basically, clustering is very limited to categorical data. And since it means grouping things and grouping things based upon the features that you guys have, it is very subjective. What do we mean by subjective? Let's say here in this houses example, I considered color of the uniform to separate the students. Let's say you do not do that, and instead, what do? You say ki everyone stand according to your classes. So then you have class first student standing somewhere, class second student, third student, and so on. So you have completely ignored the fact that there is a color of uniform that is making them distinguish, and you have considered a separate factor that is the class they study in. So clustering is completely subjective. It depends from person to person. All right, let's wrap up with this theoretical part, and I'm going to ask you what can be the real world application. You guys are working on various projects, and some of those might be related to e-commerce. Can you think of any particular application of clustering in e-commerce? Yeah, product categories. There are various examples. Phones with different colors. No, phones with different colors, though you guys can do that, but some examples which are meaningful or which are adding to the industry, basically helping them with their sales. Basically, customer segmentation can also be an example of clustering. So, since e-commerce industries they rely heavily upon their customers, yeah, ratings can be one thing. Okay, so what do you guys can achieve with the help of clustering? You can segregate customer behaviors. Okay, someone who is purchasing, uh, let's say a specific category of things. Only someone who is interested only to purchase during winters. So all of these behaviors they can be studied and the customers can be segmented. Yeah, brand separation could be another example. All right, so I think that clustering is quite clear to everyone, and we are going to take a 3 minute break, and after that, we will study our first clustering technique that is K-means. A short break, and everyone be back. All right, do we have everyone here? Let's have a look at k-means, and for that purpose, I have a presentation that I made a while ago. So we are going to learn about k-means clustering. This is the presentation that I made during my interview process. So I was asked to demonstrate and to teach about k-means clustering. Some of you guys might remember. Okay, so I'll be teaching about k-means clustering again today, and I hope to make it easier for you guys to understand. So if we talk about k-means clustering, it is an unsupervised learning algorithm that is going to partition the data into k different clusters. Again, you will find it like on the surface level, you'll find it very similar to KNN. Basically, KNN is k-nearest neighbor, k-means is well k-means clustering algorithm. We'll talk about their differences after we are done with k-means clustering understanding. So here also you need to define the value of k, and based upon this value, it is going to partition your data set into k different clusters. This is an iterative algorithm. Okay, iterative means that it is going to execute repeatedly. Okay, some steps they are repeated repeatedly in order to classify the data points into clusters. And the clusters that it makes, okay, it is going to make them in such a way that each data point belong to only one cluster. Basically, some of the clustering algorithms they are in such a manner that they perform overlapping clustering, which means one data point it could belong to two clusters. But KNN it is a non-overlapping clustering technique, which means that the clusters they will have a clear boundary, and no one data point will be part of two or three different clusters. It is going to belong to one cluster only. Now let's have a look at the steps of k-means clustering. Okay, so we talked about that k-means is iterative, and we'll understand in a bit why k-means is iterative. Let's say I have this one-dimensional data on a linear axis, and what I'm trying to achieve. Okay, there is no data. You can guys can imagine that all of these data points. Right now, you can see that there is a clear distinction between these three because you are able to identify these three colors. But consider that these are not colored, all of them are gray. And what you are doing, you are working to find some kind of uh, similarities between these data points. All right. So, how are you going to assign them to a respective clusters such that you have this result? Are you able to understand what I'm saying? For initial state, you're going to imagine that this data that I have over here, all the points are of gray color, like this one. Okay, and there is no boundary of any sorts, and you are working to classify the data in such manner. Okay, so these 4 points they should belong to red, these 4 points should belong to blue, and these 4 points belongs to three. So if you are applying k-means clustering algorithm upon this problem, the first thing that you need to do is you need to identify the number of clusters. Okay. So here, the value for K, basically in KNN, you would be assuming any value and then you'll be trying with another value. That is a hit and fail concept. Here in the beginning, you can choose any value from 1 to 10, but there is a specific a method by which you can confirm which is the most suitable K value for your K-means algorithm. But firstly, we consider three. Okay. So since this particular algorithm, it is a centroid-based algorithm. So each cluster is associated with a centroid. So what do we mean by centroid? Basically, the center of each cluster. So the three clusters that we are aiming to form, each of these clusters is going to have one centroid. Okay, and in the first, basically this centroid selection, it completely happens randomly. Okay, so you can select any three random centroids. Then step three is to measure the distance of point 1 from the selected centroid points. Let's say for these clusters that I have, okay, I'm planning to make three clusters. I select red as the centroid for the red cluster. I select this blue point for the centroid of blue cluster and this green point for the centroid of this green cluster. Got it? Now, when I get my centroids, what I'm going to do, I'm going to measure, let's say this first point, I'm going to measure its distance to the red point, to the blue point, and to the green point. And whichever cluster centroid is the nearest to this particular point, I'm going to assign this data point to that cluster. Easy approach. We were using a similar kind of approach in KNN as well. Now, what you guys are going to do, you're going to change your centroid. Why you are going to change your centroid? Because you have just assigned a new data point to this red cluster. And since you have a new data point, earlier there was only one single data point and that was the center. But now since there are two data points, the center of the cluster has changed. Do you guys agree with it? Please give a thumbs up if you agree. So what do? You again find the center of your cluster. So let's say this dotted line, it is the center of my cluster now. So since you have got this dotted line as the centroid and blue and green, they have the same centroid still. So you repeat the process. That is, you will see for the second point now, you'll measure the distance with the centroid of red point. Yeah, the centroid of red point, the centroid of blue, the centroid of green. And again, since it is closer to the centroid of red, you're going to assign it to the red cluster. Since you have added a new point, again, update the centroids. Repeat these process. And these repetition, it makes k-means an iterative algorithm. Once you repeat this process, basically checking the distance of each data point with the cluster center and then updating the cluster centers, you're going to get some kind of result. Okay, when the whole data points are classified. So the result that we get from the first iteration is this. And the expected result was this. You can see that there is a clear distinction between the observed result and the expected output. Can you tell me why is there an observable difference between the two? We performed all the approaches, we performed all these steps, followed them religiously. Still, there is a difference between my output. What could be the reason? Green centroid considered nearly. Yeah, so based upon the cluster centroids that I selected, since those were selected by random process. So since these two things, they were nearer to one another. So the data point, basically this data point and this data point, though it should be part of the blue cluster, it was assigned to the green cluster. You can see right here. And these data points, they were part of the green cluster as well. So what do you do if your result is not according to expectation? You repeat the process, whole process, and you select the different centroids, and you keep on doing it until you get your designated output. Okay, so these are all the steps that are repeatedly carried out when k-means algorithm is implemented. If you want, then you can implement it from scratch by yourself. You know all the steps involved. You know that there is a loop that is going to work since these things are repeatedly done. You need to update the cluster centroids each time. So all of these things they can be done from scratch. But since we have Python, so we have a k-means function that we are going to call and we are going to create a model for k-means. Now the data that we were talking about, it was linearly. It was linear in nature, basically one-dimensional data. What if we have a two-dimensional data? The process it remains the same. Okay, you select three centroids, you measure the distance, and you have already heard about the Euclidean Manhattan and Minkowski distance matrices. So you can use either one of those matrices to calculate the distance, just like we did in KNN. So basically, many things. Okay, the distance concept, even the name, the value of k. These things are quite confusing, and you guys can basically get lost between k-means and KNN. But if I want to describe few of the differences between the two before talking about the other concepts, let me just take you to the whiteboard. So let's talk about few of the differences between the two. Okay, KNN and K-means. So there are few very simple differences. Can you tell me any difference between these two things? KNN and K-means. Yes, guys, can you tell me any basic difference between the two? Okay, so I will tell. First of all, KNN was supervised learning. This was the last supervised learning algorithm that we studied. K means is unsupervised learning. Here the data it is labeled. Here it is not labeled. This is used for classification as well as regression. This is used for clustering. Okay. Here the value of K is the number of nearest neighbors. Here the value of K, it is the number of clusters. Okay, I'll use a different color. Let me use a darker shade. Okay. So I'll write all the things totally again. Yeah, so this is supervised. Is this color okay? Or this is unsupervised. This is labeled. The data here is not labeled. Here K is number of nearest neighbors. And here K is number of clusters. This is used for classification and regression only. And this is used for clustering. Okay, so these are four major differences between the two things. People get very easily confused between these two algorithms, but they are separate part of machine learning. Okay, completely different categories of machine learning. Now, can you tell me one similarity? I told you four differences. Can you tell me one similarity between the two? Sanjeev, tell me about one similarity between the two. It's very easy. Basically, the distance meters is that you use. Both of them works no, both of them works based upon distances. All right, and in both of them you can use Euclidean, you can use Manhattan, any kind of distance meters. We discussed about their formulas. There is very minor difference between the two, and you can use any one of them. Let's talk about one last concept before we wrap up. Today's class was entirely theoretic, and we'll be discussing about the implementation tomorrow. So let's wrap up all the theory in today's class, and we are going to talk about one last thing that is called elbow method. Can you guys recall what elbow method is? Technically, I have already told you guys about what elbow method is. Anyone, can you recall? Acha, I told you in the beginning that you know the value of K. there is a graph between some x and y. Amotoj can recall it correctly. Yeah, definitely there is a graph between x and y here. We will see what is that graph. So elbow method is a method that is used to find the optimal value of k for k means. This algorithm, it heavily depends upon this value. Okay, if the value is wrong, the algorithm won't work very well. And this is one of the disadvantage of this algorithm. Okay, so in order to get the optimal value of k, in order to make this algorithm work its best, we use a technique that is called the elbow method technique. So what is going to happen in this particular technique? First, we will discuss about. So we got to know that the performance it many matters and it depends upon the value of k. Second thing, that this method it is going to find us the optimal number of clusters for one particular data. And how does this method works? It basically involves calculating within cluster sum of squares. Basically, this is also represented by WCSS. So what is within cluster sum of square? Like if I have a cluster like so. Okay, so there is this cluster. Okay. Let me just enlarge it a little bit. Okay, so there is this cluster. This cluster will definitely have a centroid. We very well know about it. Let's say this is the centroid of this cluster. So what is WCSS? WCSS is nothing but the distance of each point. Can I draw a straight line here? Basically, the distance of each point from the cluster. So this distance, this distance, each and every point's distance. Let's say if I make it a little bit cleaner, let me use a different color. Yeah, so let's say this distance and this distance. So likewise, I'm going to do what? I'm going to measure the distance of each data point from the centroid of the cluster. Let's call it that this is D1 and this is D2. Okay, so what do? We calculate all such distances. Let me change the color again. Yeah, we calculate all such distances and we perform the squaring of these distances. Let's say this cluster it has endpoints, so all the distances. And this is called what? This is called WCSS for this particular cluster. Okay, so what is within cluster sum of square? It is some basically all the meaning is conveyed by the full form itself. Within cluster, okay, and in a particular cluster there is one centroid. You're going to measure the distance of each and every data point from this centroid. You're going to add all such distances together and you'll get the value of within cluster sum of square for cluster 1. If you have another cluster, you're going to do the same with that as well. Let's say cluster 2. We're going to calculate the distances for all such data points from the centroid. And the total within cluster sum of square is what it is WCSS1 plus WCSS2. Since there are two clusters for a data. If there are three, then you'll also get the third within cluster sum of square. Okay. So the graph that Monroe was talking about, this is the graph. So in KLN, what do we do for different values of k? Let's say generally you can take value from 1 to 10. You can go beyond that, but it is completely unnecessary to go beyond 10. So what do? We calculate. We basically run the algorithm for different values of k on the same data. And for all the number of clusters, we are going to calculate within cluster sum of square. So this graph, it is between x and y, and x here is the number of cluster and y here is the WCSS. You can see that for cluster 1, the within cluster sum of square is very high. Okay, and obviously it will be very high since you have clustered all the data points available in your data and you have formed a one big cluster for that particular data. Then you will see that for cluster 2, for two number of cluster, there is a very significant drop in the number of in the value of WCSS. Then you can see that there is one. After that, you can see that there is a very significant drop. But after like between 3 to 5, after 5, there is not much difference. So you will see that each time you draw a WCSS versus number of cluster graph, this is a pattern that you will observe in that particular graph. Firstly, the WCSS will be very high, then it will be very low as the number of clusters increases. So in this graph, in order to find the optimal number of clusters, you look for a particular place, and that particular place is known as the elbow of the graph. Elbow, or some people also call it knee. So what is this elbow knee? It is a sharp bend. You can see that in this particular graph, there is a sharp bend here. In this bend, it tells you the optimal number of clusters. Can you can you distinguish? Okay, in the graph, can you distinguish the significant location of this elbow? Okay, there is a sharp bend that is obviously visible, but can you see another significant thing with respect to this bend? Is there anything observable? What is the difference between the slope here and the slope here? You guys are quite good in mathematics. Tell me what is the difference between the slope. Yeah, so Mortwaj has very aptly explained. The slope is changing from positive to negative at this point. Okay, so the sharp bend, okay, it basically also sees a very significant difference between change of slope, direction of the slope. So this tells you what is the optimal number of clusters for your data. And this particular bend, it generally lies between 3 to 7. Okay, all the data that I have worked upon, I am easily able to observe between 3 to 7 clusters. Okay, but based upon any real-time data, this could be like different for different data. So you can use this method to get the optimal number of clusters. So, all right, let's wrap up the class with a few and disadvantages of k-means. So when we talk about advantages, it is easier to implement and it is faster on smaller data set. Though this is an iterative algorithm, it is very slow or very time consuming on larger data set, but it is easier to implement on smaller data set. It is going to identify unknown groups in large data set. Definitely, it is a clustering algorithm, and it produces compact and tight clusters, which means that the clusters they are non-overlapping. One data point belongs only to one cluster. Disadvantages: it forms spherical cluster only. Why is this a disadvantage? Because in the real-time data that we are going to deal with, very rarely you will find that the clusters or the data it is easily separable. So forming spherical cluster, it is some kind of shortcoming of a cluster algorithm. Another disadvantage is that it is basically sensitive to outliers, which means if there is an outlier present, the sensitivity of the cluster will change. And it is basically going to try to classify that outlier in some of the cluster. So the whole algorithm, it is not going to produce a correct result. And obviously the number of cluster, it must be specified before. So this is a disadvantage. All right. I hope that clustering and key-means is very clear to everyone. And Uh, if you guys have any doubts, you guys can discuss. I believe that today's class was somewhat boring, but it was important to understand it. So thanks for bearing the whole lecture. Yeah, so if you guys have any doubt, please feel free to ask. We'll continue with the implementation tomorrow. If there is no doubt, you guys are free to leave the session. Thanks for attending.